Regents Review number 24. For question number 1, it shows you some pictures in a sequence. And then it asks you to determine the formula that represents this sequence for the number of squares in the nth term. So as we see here, we have some gray squares amongst the white squares. And the first shape has 12. The second shape has 16 gray squares. And then the third shape has 20. And so we can see here that it's increasing each time by 4. That means that this is a linear pattern, or you could describe as an arithmetic sequence. So there's two ways to look at this. One is to look at it like a linear pattern, which uses this formula. And the other is to look at it as an arithmetic sequence. And if you don't remember that formula, you could always look it up on your reference sheet. So in an arithmetic sequence, the answer for any number in any position is the answer in the first position plus the common difference times the quantity n minus 1. So I could use either one of these formulas. This one is more of like an outline. It's a cookie cutter. You put the numbers in. You don't have to do much thinking. This one requires some more understanding on your part. This equation is a bit harder because this value represents the rate of change, or the common difference, but this value represents the initial value, which actually isn't shown on this page. The initial value is the answer in the 0 position, or term 0, which isn't shown. I'm sure you could figure it out, but it's not shown technically. So I'm going to use this formula here and manipulate it so that you can get it back to that formula if you quite don't have all that understanding. So the answer in the n position is equal to the amount of the answer in the first position. So for us, that's 12, plus the common difference, which is 4, and then the rest is the quantity n minus 1. Now you can rearrange this formula here by distributing the 4 into those parentheses, giving you 12 plus 4n minus 4, and then combining like terms, which would leave us with the answer in any position is 4n plus 8. Now, if you did not use the arithmetic sequence formula and you used the linear equation formula, then we already know that the common difference is 4, and then we would get our answer in the 0 position by working our common difference in reverse. So instead of adding 4 to 12, we would subtract 4, and that's where the 8 comes from. Question number 2. Which equation represents the line that passes through these points? Again, there are two ways to solve this. You can solve this by using the point-slope formula, which requires you to find the m value using this slope formula. A second technique is to use your TI-84 by entering these values into the stat, edit, list 1, list 2, and then computing them using the stat, calc, number 4, lin reg button, since it is a line. So let's get started with the calculator, then I'll show you the formula. So with the calculator, you press your stat button here on the second row. You enter the points into list 1 and list 2. So my x values are 1 and negative 2. And then I move over to list 2. My y values are 1 and positive 7. Then I go back to my stat button here. I arrow over once to calc. I choose number 4 lin reg, and I press enter 5 times. And there's the equation. Y equals negative 2x plus 3. Now, if I did not have a multiple choice, and I had to show my work, then I would use these slope and point slope formulas. I would find my slope by subtracting my y's in the numerator and my x's in the denominator. That will give me my m value of 6 over negative 3, also known as negative 2. Got my first number already. And now I need to find my b value. I can use this formula, or I can use this formula. Both of them require a slope, and both of them require an x and y point. Any point you want. You can choose either one of these points. Both will work. Now with this one, when you're done, you'll find b. With this one, when you're done, your entire equation will be written. So let's see. If I use my point slope formula, and I use this point, which is a great point to choose because the x and y values are the same, and you can't mess it up. So y minus 1 equals negative 2 times x minus 1. Y minus 1 equals negative 2x plus 2. Add 1 to both sides. Y equals negative 2x plus 3. Same answer. If I wanted to use the slope-intercept formula, then I would do the same thing. Insert my x and y values here and there. Put my slope value in. Compute. Solve for b. And then know that I need to put these two items together into the formula myself. Question number 3. A satellite television company charges a one-time installation fee. One-time fee is known as an initial value, which is also known as a y-intercept, which is also known as the b value, right? And it also charges a monthly service fee. Now, if it happens every month, per month, that would be the slope or the rate of change. The total cost can be modeled by this function, y equals 40 plus 90x. So it's important for you to know that the y-intercept is the constant and the rate of change is the coefficient of x. So now that we know where each piece goes, we can interpret its meaning, which is what they're asking. Y is the total cost, X is the number of months of service, 90 is the installation fee. So if that's the installation fee, they're saying that this is the initial value. And if you look carefully, we can see that it's not. The constant value is 40. So this one is wrong. Y is the total cost, X is the number of months of service, 40 is the installation fee, yes, and 90 is the service charge per month. Very good. So we know that this one is probably correct, but you might notice that the initial statement here is different. So we have to focus and make sure that we understand that Y is the output and X is the input. So X has to be what's changing. And what's changing is the months of service. So X has to represent the months of service, not Y. So that means option 2 is the correct answer. Number 4 asks you to find the x-intercept of this graph, and an x-intercept has a y-coordinate of 0. Which means that if you have an equation, you can replace that y value with a 0. Anything that's multiplied by 0 is 0, so that leaves us with this statement, and that means that x is 10. Question number 5. The population initially has 20 birds. Okay, initially means that that's the y-intercept, the initial value, or the b term in an equation. it doubles every 10 years. Now, if you are doubling, that means your rate of change is timesing, which is exponential. So if I need to match it with a graph, I already know it's exponential. It cannot be linear. And I already know that the initial value is 20. So my initial value has to be at this number 20. That means option 1 is wrong. Now it also says that the population doubles every 10 years. That means that if I start at 20 birds, then the next year, every 10 years I'll double. So in 10 years I would have 40 birds. That means I am increasing. So this one can't be right. That makes option number 3 the correct choice. Number 6. Let f be a function such that f of x equals 2x minus 4. It is defined on this domain. That means in my x chart, I can start at 2, but I have to end at 6. And I can put any other inputs I want in between. I can put a 3, I can put a 4, I could put a 5, but I also could put a 3.7. Right? The domain is any numbers as long as they are between 2 and 6. It also says it can be equal to, right? It can be equal to those values. So if I want to know the range of this function, then I need to know the outputs for 2 and 6. Now I can either do that by hand. I can put those two inputs in and figure out the outputs. I would put a 2 in here, I'd put a 6 in here, and I would figure out those outputs. So it looks like this one would have an output of 0, and this one would have an output of 12 minus 4, which is 8. Another way that I could do this is I could check it on the table using my TI-84. Right here in the y equals button, I can type 2x minus 4. I can look at the table, starting at 2, which is 0, and ending at 6, which is 8. So both methods work. Now, since my beginning value is 0 and my ending value is 8, that means that y is in between 0 and 8. Since both of these had equal to signs, the range will also have equal to signs. Therefore, the answer is 1. Number 7. Which graph shows a line where each value of y is 3 more than half of x? Y is 3 more than, that's a backwards translation, half of x. So that means my y-intercept has to be 3. 3, 3, 0, 3. So this one's out. It looks like my slope is increasing. So that means my line has to be going uphill, 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 downhill. And now I need to make sure that I am increasing on my y-axis and my x-axis the appropriate values. So let's take a look. I'm going to find some perfect corner points. Let's see here. Perfect corner points, perfect corner points. Over here, perfect corner points. Here. Alright, it looks like graph number 3 has a delta y of 2, 1, 2, 1, 2, 1. And that's not correct. And this one has 1, 2, 1, 2, rise 1, run 2. So that means option number 2 is the correct value. Number 8. What is the value of x in this equation? I think I'm going to clear my denominators by multiplying each term on both sides by 6. That will leave me with 2 times the quantity x minus 2, 1 times 1, and 1 times 5. How I can distribute? 2x minus 4 plus 1 equals 5. 2x minus 3 equals 5. Add 3 to both sides. 2x equals 8. Divide both sides by 2. X is equal to 4. And that concludes Regents Review number 24.